Okay, guys, you're ready? I have posted another figure for this calculation. The figure that I showed it as a last slide before ending the session. So it's in the, let's say, Zoom course environment. So this is for 19 PMT calculation, and it can be extended to any number of PMTs with this formula. So these quantities are vector quantities, and these quantities are scalar quantities. Now let's continue. Okay. Pulse height analyzer is basically selecting the desired or undesired pulses after calculating the scintillation coordinates in 2 dimensions. So basically, it's a kind of threshold detector. There are some additional systems, subsystems for that. Due to scattering, etc., there may be some delays in the, let's say, scintillation moments, etc. And those other types of subsystems are a bit details. I'm omitting those, left as a reading exercise. So let's look at some image and its characteristics. Let's read a little bit. Planar scintigraphy, signal to noise ratio, contrast to noise ratio, and the definitions, etc., are left as an exercise for planar tomographic or scintillation systems. Now, after finishing, we come to single photon emission tomography. Basically, this is an image of whole body when the bone regions are radioactive. Mostly the radioactive tracer are gathered in bone regions, and so the detector is rotating around the body. There may be multiple number of detectors. They are all rotating around the body to form the tomographic image. So this is the system, appearance of the system with 2 detectors, 2 gamma cameras. Okay. And it's highly computerized, data processing, scatter correction, etc. Those are too much complex for the time being, so I left this as an exercise for the curious people. Okay. And image reconstruction is a little bit advanced, so good for graduate level courses, not suitable for undergraduate course of ours. Now we come to SPECT CT. Since 2001, there has been increasing trend to combine SPECT, which is nuclear medicine, and CT, which is X-ray CT, because this is a physiological imaging modality. This is an anatomical imaging. So if you combine it, that's very valuable for the doctors. So in 3 years, starting with 2008, there were approximately 1,000 combined SPECT CT systems. So they both send gamma rays as well as X-rays. Actually, they sent X-rays with X-ray. So the patient sends gamma rays. So these 2 detectors, gamma camera here in the SPECT region and X-ray tube and detector in the X-ray gantry. So here's the look like of all systems. This is a little bit thicker because 2 systems are side by side. So this is a combination. So there are many SPECT CT systems in Turkey as well. And the clinical applications of SPECT and SPECT CT are outlined here, which is not the topic of our course because it's mostly related to biochemistry, clinical applications, results, structure of heart, the problematic conditions of heart, etc. There are, of course, some state-of-art systems to monitor heart conditions in SPECT-CT kind of approaches. Their detector, collimator structures, etc. In principle, they are the same as our planar scintigraphic equipments. There are some special systems for brain, for heart, etc. You see, here's an image of the brain, and the problematic things are indicated, and some hardware about complex tube in an Anger camera of these kind of systems. You see, this is a kind of scintillation or annihilation point, and these detectors receive some, but mostly around this, which are closer to the scintillation points. Number of detectors can be as large as possible. Large is better, but more advanced. So radio tracers used in PET and CT are again almost the same as our other radio tracers, except specialized heart and brain investigation require more specialized radioisotopes, which are listed here, and their chemical structures, etc., are stated. And of course, their detectors are more advanced, so these are also left as a reading exercise. The systems identically exist. Crystals, collimators, photomultiplier tubes, pulse height analyzers, coincidence detectors, etc. are also in those kind of systems. For example, look at a combined SPECT CT system. This is only nuclear imaging output. This is CT output. Then you combine them, get the boundaries of the organs, etc., and more valuable information can be given to the doctors. Data processing in PET and CT is related to computational science or informatics. Of course, nowadays, all the systems are computer controlled and data are manipulated by utilizing digital approaches. Okay. So there are some information for the interested reader to the informatics. You are not responsible to those parts of the concepts. And again, clinical applications of PET-CT. It's very similar to SPECT-CT. SPECT is gamma ray below 511 keV. PET-CT is gamma rays of 511 keV and normal computer tomography or CT scans and their images, cardiac images, brain images, etc. There are some exercises about radioactivity and collimator design, SPECT issues, PET issues, and of course, references. So that's about it. So this week, we have completed nuclear medicine and SPECT, PET, and CT. And we will continue with the issues next week at the usual time. But I will end this session, Zoom session, but don't go anywhere because as soon as we end, please enter so-called BBB session. Okay, where is that BBB session? Let me show you. Let me show you where it is. Okay. Okay, that's. Now, in that Zoom course page, week 6, 12 April, okay, you have some events, okay? First of all, or some files. The file lecture slides had been covered in the first session, first hour, and we are now in online lecture with Zoom. I will end this Zoom, and as soon as I end, I will open up that BBB session. Please enter that session because I want to take an attendance file with your name, attendance names. Okay, so I will collect the number of attendees by using BBB. And this is the file containing the method of calculating the exact coordinate of the PMT tube. Do you have any questions so far?
Hocam ödevlerle alakalı bir şey sorabilir miyim Türkçe bir şekilde?
Ya Aybüke, hep İngilizce sorsan ne olur ya? Hep böyle yapıyorsun ya.
Tamam hocam, özür dilerim.
Soramaz mısın?
I couldn't exactly understand the homework number 3. It says it will be the merge of the homework 1 and homework 2, but are we going to do something new, or are we just will we just merge our reports of first 2 homework?
Your English very well. Please speak in English always.
Thank you so much.
You're welcome. Okay, merging means, okay, that's a general request. Some people had done very good line spread function homework, but not so good modulation transfer homework. Some people had done not so good LSF, but very well MSF. So homework number 3 is doing the best of all times, okay? You have to redo your experiment. But if you are very good, then you can completely cut and paste the first homework and the second homework, okay? But I told you, gave some feedback to generally all of you. Many homeworks are not as good as I desired, except the ones that I submitted as good examples, okay? But the classroom contains 77 people or 154 homeworks. The good ones are 15 or 20. So homework number 3 is a chance for everybody to do missing or bad, not so good parts, and submitting the final digital camera quality measurement experiment. Okay?
Okay, thank you so much.
Yes, that's what you are required to do. You have to submit it on Monday. Also, I gave another homework, which is a research homework through internet. Definitely you will not go to hospitals nowadays or towards the end of semester, that's for sure, but you will do your homeworks through internet. So the first phase is to find a commercial X-ray equipment and doing research about the electrical and electronics engineering aspects. Do not find internet page because usually they have advertisement sentences. You will be searching deeper related to electrical and electronic aspects of these systems with the guidelines that I gave to you. I will continue same type of experiments with nuclear medicine, SPECT, PET, CT, and all kinds of imaging equipment till the end of the semester. And again, we'll give a cumulative homework to submit the best of best. You're welcome. Good luck. Any other question? No question. I'm ending this Zoom session, and immediately after opening so-called BBB session, register or attend that session to have your attendance information. Okay, thank you.